Good day! In this video, we are going to look at 3 questions on how to solve the binomial distribution question using the graphic calculator. So before we even do the binomial, we need to know what are the conditions for it to be a binomial distribution. So the conditions are set here, 1, 2, 3, 4. And if you want to get merit or excellent in this paper, please make sure you remember all these 4 conditions. First, it must have the fixed number of trials. Second one, the trial must be independent of the others. Third, the probability of success at each trial must be constant. And last but not least, each trial can only have 2 possible outcomes, often referred to as success or failure. This is very subtly different from the Poisson distribution based on factor number 1 and number 4. Okay. First, it must have a fixed number of trials. I mean, for example, you have 6 out of 10 or 20 out of 100. That is called a fixed number of trials. They must have a number of trials stated there. Secondly, the difference between the Poisson and binomial is that the trial has 2 outcomes. Yes or no, success, failure, or whatever. It must have only 2 outcomes. So if this you can find that these 2, then you know that it's a binomial. Okay, so without further ado, let's try to solve this question. Okay, next question, I need a graphic calculator, so I'm going to bring my graphic calculator along. So I'm going to move this a bit to the left, and we're going to solve this question. Hope you can see the graphic calculator. Yep, I'm going to adjust. Okay, so the question is, a lawyer successfully defends 1/3 of a client who are charged with driving offences. Find the probability that 5 out of the next 8 clients that she represents are found guilty. Found not guilty. So you can see there's a fixed number of trials. There are 8 clients. So out of the 8, what is the probability of 5 out of 8? And secondly, is guilty or not guilty? So there's a 2 outcome, yes or no, guilty, success or failure, and so forth. So there are 3 key numbers you need to key in the calculator to solve this problem. First, you make N, P, and X. N is number of trials, okay? P is the probability of success. And last but not least, X is the probability they ask, okay? The probability the question asks, okay? So for example, in our case, 5 out of 8, so X must be equal to 5. N is the total number of trials, so there are 8 clients, so N equal to 8. And P is the probability of success is 1/3. Once you know this, we can use the calculator to solve this. So we're going to do it, the slide that I have prepared. Okay, so we're going to just take it off, okay? And we are going to do it together. Follow me as we go along. So what we do, we're going to just put in a graphic calculator. So we are going to go to statistics there, okay? So execute, okay? Now we're going to do distribution, F5. Then we're going to do binomial, again another F5. Okay, there are 3 numbers there, BPD, BCD, and inverse binomial. In this case, because there are 5 out of 8, we have to use BPD, okay, BPD, F1, okay? If they say more than 5 or less than 5 is a cumulative, then you do BCD. So in our case, 5 out of 8, so we have to press the F1 button, which is BPD, okay, BPD, F1. Okay, now we need to key in the data. Remember, always do in variable, so go to F2, and we are in variable, okay? And execute them, so exit, okay? So you need to go down, okay? Then first number is X. X is, as I said before, 5 out of 8, so X have to be 5. Then followed by number of trial, which is 8, 5 out of 8, so N is 8. Probability of success is 1/3, so 1, A, B, C, 3. Then the last step, you do execute, and execute twice again, and the answer is 0.068282227. If you can get it right, and that will be how you calculate a BPD question when they normally ask you 5 out of 8, 10 out of 20, or 2 million out of 10 million, okay? So that is called a BPD question, okay? Now we are going to do the second type, which is called the adding binomial. Okay, I'm going to get this out so that, okay, we read the question while I try to reset the button for the calculator. So main and then F1, and then we're going to do exit, and then we are ready to go, okay? F2 again. Yes, and then we are ready to go now. Okay, so now back to stats, okay? The probability Okay, I hope you can see. Okay, we're going to adjust. Okay. The probability that a certain profile user had their cell phone on at 6 p.m. is 0.73. So success is 0.73. What is the probability that out of the 60 chosen users, so n is 60, the total number of people is 60, okay? 39 or fewer have their cell phone switched on. So again, this is adding binomial. In other case, they are calculating the numbers, okay? Hopefully you can see, okay? They are adding the numbers from 0 to 39 because less than 39. 39 or fewer, okay? So now we are calculating the probability of 0 to 39. If you want to calculate BPD, you can do it one at a time, 0, 1, all the way to 39, and add, you get the answer. But fortunately, the graphic calculator has a function called BCD. BCD will calculate the number from 0 to wherever it ends. In our case, it starts from 0 and ends at 39. So your X had to be 39, okay? N is a total, there are 60 of them, so N is 60, probability success is 0.73, and now we're going to solve it using the graphic calculator. Okay, so again, we are going to go to statistics, execute, distribution, and then binomial, F5. Now, remember, you are accumulating from 0 to 39, so this time it has to be BCD, which is F2, okay? F2. Now, again, go to variable, F2. Now you're going to key in the data, okay? X is going to be 0 to 39, so where it ends is going to be 39. So X equal to 39. Number of trial was 60. There are 60 cell phone user. And then success is going to be 0.73. Execute, and the probability is 0.1074241. So hopefully you understand. The BPD is 4 out of 10, 12 out of 20. Adding binomial is 0 to whatever number is top. So in this case, we want to calculate probably 0 to 39. So X had to be 39 and do the same thing. So accumulative. So BCD is the cumulative. Okay, now we're doing the last question, which is the NCA question. Okay, we shall read the question and we bring the calculator later. Okay, the question reads like this. Okay, so lightning strike affected 16% of all hectares of pine tree in New Zealand. So success is 16. P is 16 or 0.16. Okay. You always put in decimal, 0.16. A farmer had planted 18 hectares, so N equals to 18. And assume a lightning strike in 1 kilohectare is independent. Calculate the probability of at least 4. At least 4 means they're looking for probability of 4 and above, probability 5 all the way to 18, okay? So now we are going to calculate using the calculator. And you know the P is 0.16, N is 18, and you are calculating probably from 4, 5, 6 to 18. Okay, so again, as I said before, you can actually be doing BPD for 4, 5, 6 all the way to 18, but it'll take a long time. So you can calculate probability of 0 to 3, because 0, 1, 2, 3 plus 4, 5, 6 to 18 is always equals to 1. So probability of X equal to 4, 5, 6 to 18 is 1 minus from X equal to 0 to X equals to 3. Okay? So now, if we can do BCD on X from 0 to 3, means X equals to 3, success is 0.16 and total is 18. We can use that 1 minus that probability, gave the answer. So we shall do that again. So menu, go to statistics, okay? And then again, so exit. So we're going to start distribution, binomial, BCD, and now X is going to be 3. Execute. Number of trial is 18. Execute. Success is 0.16. Execute. And the answer is 0.67713. But don't forget, you need minus 1 from it. And the answer is 0.32287. If you don't understand why I minus 1 from it, it's because 0 to 18 is going to be 1. If you want to calculate 4, 5, 6 to 18, you just take 1 minus 0 to 3, and that will give us the answer of 0.32287, and there's a merit in this paper for normally in every NCA question. So if you have a go again, play around with your calculator, and I believe you should do well in this paper. Cheers everyone, have a good day.